time of year again, getting ready for Christmas.
Oh, yeah.
I was getting out my Christmas lights, and I plugged them in, and I realized that none of the lights turned on.
That is so annoying.
Should I just throw them away?
Well, that seems like an awful waste.
Well, my grandma always used to tell me that once a string of lights doesn't turn on anymore, it's broken.
This sounds like a case for the MYTHBUSTERS!
So what we have here is a kind of a model of the same string of lights you had. As you can see, it's a perfect circle of our energy source and our lights connected by a string of wires. So since we have this model, why don't we try and figure out what happened that made your light stop working? My first thought was maybe it wasn't connected to your power source. Take a look. As I disconnect here, look what happened to the light bulb. When I reconnect, the light bulbs turn back on.
But I know that couldn't have been the problem because I'm sure they were plugged in.
Well, maybe there was something wrong with one of your light bulbs. Maybe it was broken.
Well, what would happen if one of the light bulbs was broken?
How convenient, because I have this hammer. So why don't I give just a good hit to this light bulb and we'll see what happens to the others in the series circuit. Oh. Ooh. Take a look. You'll notice that none of the light bulbs are on, but if I try and fix it, they're all on again.
Well, this kind of circuit doesn't seem like a very good idea. How long would it take me to try and figure out which light bulb was broken so that I could fix it?
Absolutely. This only has 3 lights. Imagine anything more than 20, 30, or 40.
Or 100.
So I wonder, I mean, this is one design for a circuit. Do you think there's a better design we could create that would stop that problem?
Let's try and figure it out. So the circuit we were just working with was a series circuit. Now we have another type of circuit in front of us.
So if you look down here, you'll notice that it's in a different formation. We have our power sources, which connect to our light bulb. 2 more wires connect to our second light bulb, and even 2 more wires connect to our third light bulb. Now, let's see what happens when I use my hammer to put one of these lights out. What do you think is going to happen if I try and break this one?
Well, it'll probably be like a series circuit, so all the light bulbs will go out.
Should we give it a try?
Let's try it.
All right, take a look. Oh, very interesting.
At the other 2 light bulbs.
Wow, they're still on.
How does that happen?
So I smashed that pretty good, but check it out. This light bulb and this light bulb are still on. Now, if I unscrew this light bulb, this one even continues to stay lit. So clearly there's a major difference between this circuit and the series circuit we were learning about before.
So the first circuit we looked at was a series circuit. And like we saw, all of the light bulbs were connected by only 1 wire. So if 1 light bulb went out, all the rest of them also went out.
Then, when we looked at our parallel circuit, the second circuit today,
What you'll notice is from the power source, there are 2 wires connecting to each light bulb. So if this light bulb burns out, then the wire continues to the next light bulb, allowing those electrons to continue their path. These light bulbs are able to stay on.
so after all that investigating, it really does sound like we found a solution to your problem.
Definitely. Now I know that even though it might take a while, I could definitely fix my string of lights.
Absolutely. And next time you go to buy a string of lights, you need to ask for a parallel circuit. That way, if one light goes out, all of the lights stay on.
Well, just like that light bulb earlier, sounds like this myth is
Busted!